Okay, cool. There we go.
Yep.
Cool. Hello, everyone. My name is Sonny. I'm a staff engineer here at Stacklet. Excited to talk to you about Custodian, which is really just a funny way to talk about the new event-driven policy execution mode in Kubernetes with Cloud Custodian. So to get started, let's talk a little bit about the state of Kubernetes support in Cloud Custodian today. The provider was created in September of 2018. And the general idea around the provider was to say, if you already knew how to write policies for your public cloud, you could bring that same experience, vocabulary, and ergonomics to Kubernetes as well to govern your cluster. There are currently 16 resources that are supported, and that also includes custom resources, so objects that you create through CRDs as well. It's pull mode only. And there's a few actions, but really there's like a label action, a patch action, and delete action. So it's pretty still early stage and hasn't had a lot of use. But today we're going to try to change that with this new event-based policy execution. So here's a sample policy. If you're familiar with the AWS provider or Azure GCP, it looks very familiar. You have a name, you have a resource description, and then your filters here. So this is very similar to a tag compliance policy that you might see in any of the other cloud providers, right? In this case, we're saying if the recommended labels here, name, instance, version, component, part of, and managed by, if any of these are absent, filter in the resource and call it missing recommended labels. So what do these event-driven policies in Kubernetes look like? Well, we already know what event-driven policies for AWS, Azure, and GCP look like. And that's in the form of a mode. So today we're introducing a new mode that can operate off of these Kubernetes API server events. We had a few things that we wanted to tackle and make sure that we had for this new mode. One, that it needed to be comprehensive. So full support of Kubernetes resources out of the box. Two, it should be configurable. So we should be able to operate on all of the lifecycle events on those resources. That would also include the ability to specify which events you don't care about as well. It needs to be ergonomic, so have it feel like it's native to the Cloud Custodian policy language. We didn't want something that was completely out of the box and you had to basically rethink how to write your policies from scratch. And four, it needs to be easy and needs to have documentation examples from day one so that it's ready to use, ready to be consumed by the community. So it's a new mode. It's called Kate's Admission, or K8S Admission. It supports all the existing resources as well as custom resources. So this covers off on the comprehensive part. We can allow, deny, or warn on object creation, update, delete, or connect. So this is basically just vocabulary that Kubernetes has around the different event types. So it's much simpler than something like AWS, where, for example, to create an EC2 instance, you make a run instances API call, and to create a bucket, you would create a create bucket API call. In this case, it's all standardized, create, update, delete, or connect. And the vocabulary for the action that you want to perform here, allow, deny, or warn, is also standard. We can validate and mutate objects as they come into the cluster. And it uses the same simple custodian policy language as you expect. Finally, it's easy to run the cluster, and we'll give some examples of how that works in a second. So for a quick architecture overview, first, it utilizes Kubernetes admission controllers. So for those that are unaware or may lack some Kubernetes experience, this is a definition from the Kubernetes website. An admission controller is a piece of code that intercepts requests to the Kubernetes API prior to persistence of the object, but after the request is authenticated and authorized. So what does this mean? One, it means that the Kubernetes admission controller itself does not actually have to care about auth Z or auth N, right? So when the request comes in, we can assume it's ready to go. We just have to check for correctness. Two, this also implies that we can actually operate on the object prior to it ever existing in the cluster. And this is a little bit different from, say, the AWS CloudTrail mode or some of the other event-based modes that are available on the other cloud providers. Those typically operate on an event, and that event has already happened, so to speak. So, for example, if you're checking for validity of tags on a EC2 instance, and you're keying off of that run instances API event, the instance itself already exists, and the remediation action then is to actually stop the instance or terminate the instance. But there's, of course, a bit of time where that might be running, and you may have, some concern about, do I want to kill like a live instance, right? In this case, the objects themselves don't actually exist, or the updates haven't been applied yet. So some examples of other admission controllers include pod security policies. Istio will deploy admission controllers, Open Policy Agent in Kyverno. Pod security policies were actually deprecated as of version 1.21, I believe. So those are kind of out of the picture, but there are a bunch of third-party admission controllers out there. So Cloud Custodian is not, coming in new with something that's never been done before. So here's a quick look at the actual architecture overview diagram. So as you can see, the API request comes in, the handler gets it, it does the authorization and authorization. Then it calls any mutating admission controllers. So here, Custodian would just be one of many of these admission controllers. There's an object schema validation. It calls the validating admission controller, and then it's persisted to etcd. So the main difference between the mutating and validating one, which may be obvious from the name, but the validating one just says whether or not we'll let the object come in or not. The mutating one can actually change the actual attributes on the resource prior to it coming in, which we'll see in a second. So you might be wondering, what does this event actually look like? So for the sake of brevity, I can't show the entire event, but it basically comes in as an admission review event. And it includes all sorts of interesting information that's going to be pertinent to the actual the event itself, including the resource kind. So this is what you're trying to deploy. The request kind, it includes stuff about who the user is that requested it, what groups that they're in, as well as basically the entire manifest that's coming in. So if you're creating a pod, you would be able to see what image your pod is. If you're creating a deployment, you can see how many replicas you have. If you're creating a service account, you can see stuff like the service account name, whether or not you want to auto mount secrets, stuff like that. So there's two components. One, a mutating admission webhook configuration. So this is the part where the Kubernetes API servers will actually call, and it defines that relationship there. And it sends traffic to the C7 and Kate service below. This is also where we define what events to filter in. And this is important because in Kubernetes, there's all sorts of events that happen on the API server all the time, right? You might think, oh, I only want to, I care about like events pertaining to pods or deployments or services or ingress, namespaces, et cetera. But there's a lot of internal events that also happen that can basically gum up your logs and make it kind of unintelligible. So that's where we can define what events to filter in. Secondly, there's the C7 and Kate service, which allows us to execute policies against the events that come in from the webhook. So again, that's where the allow, warn, and deny language comes in. And that's also where we would define our policies as well. So there's two ways to deploy C7 and Kates. One, you can use the Helm chart and deploy it inside of your cluster. You can use Cert Manager or provide your own CA certs for that, CA bundles. And this deploys quite a few things. Deploys the deployment, mutated webhook configuration, the secret config maps, etc. Alternatively, you can also deploy outside the cluster. So the CLI C7 and Kates provides you with the ability to generate the mutating webhook configuration manifest, and then you can apply that manifest to your cluster. And then on the server, you can run C7 and Kates and pass in the policy directory that you care about. So that's all well and good. Let's take a look at that sample policy again. So again, this is our effectively tagging compliance policy or missing labels policy. And if we want to change this to event-based policy, all we have to do is we add these 6 lines of YAML here where we defined our mode. And here we can see we add the mode, what we want to do when we match. So on match, we deny. and what operations we care about. And this is just all caps, create and update. So what's interesting here is the fact that for onMatch, we're able to define whether or not we want to act on the positive event or the negative, right? So some policies, it might make more sense to say we want to do like we want to check that the tags are there. Or in another case, you might think, oh, it's easier to reason about this if we say the tags aren't there and do stuff on that. Here's another sample policy. So again, the mode basically stays the same, but this time we're looking at the deployment objects. We're saying if there are less than 3 replicas, then we deny it. So this is great for like if you're trying to make sure that everybody in your cluster is deployed in a more HA sort of way, that they're not just deploying, you know, a single replica in the replica set. Here's another one, restrict service account usage. So here we're saying, if you try to deploy a pod with this cluster admin service account name, we deny it, right? So in some cases, you might have certain service accounts that are available in the cluster or in the namespace that certain people can use, but other people can't. This allows you to restrict that on a much more granular basis as the objects come in or as they're updated. This is a very interesting one. So we could deny pod exec based on the group. So for those that are unaware, a pod exec, you could think of it as you're SSHing into an instance, right? Or into a virtual machine. Here we define one additional attribute, which is a sub-resource. And here we're just checking on the event. If the allow exec group is inside the user groups, then we allow them. But if it's not, then we deny. So what's next? There's a lot of work in flight, including things like a label action, mark for op workflow, auto label user, and general mutation patching stuff coming. We're also looking at adding things like a related resource filter. So think of it like given a pod, look at attributes on the namespace or what have you, as well as things like the notify action. And I think one very interesting piece is the ability to run this in CI. So what's great about the way that the Kubernetes API works is that typically there isn't a lot of like transformation that happens in that the manifest that you create is basically the object that exists on the API server one-to-one, which means that if you write a policy, you can feed in your Kubernetes manifest into something like the C7K service, and maybe like what would be considered a dry run mode, and get that instant feedback in a much more sort of shift left way. That way, in the software development lifecycle, you don't have to depend on actually deploying your Kubernetes objects to check if they're going to work. And tools like Helm, they have the ability to just generate the manifest as well. So that's coming. There's no definitive timeline on that, but should be very useful for running in CI. So going back to the sample policy, what do all the mutation actions even look like? In this case, we just add this new action here, and this looks like any other kind of like tag or label action. We change the onMatch to warn just to have it come in instead of deny it. And here we're just going to add this missing required labels equals yes. So let's do a quick demo. And actually, I'm just very brief demo because I know we're a little bit close on time.
Yeah, go for it.
But here, basically, I've had we've got the C7K service running on the left here, and I'll just zoom in here. So here we just have a few policies that check things like the pod labels. So instead of having that entire list of labels, we're just going to check if labels foo and bar are present. So in this case, we only have foo. So if we apply this manifest, you can see here, we basically get instant feedback saying, warning, this policy name says all pods must have foo and bar labels, but it still creates the database. We also have that policy there that prevents pod exec. In this case, we prevent pod exec on any pods that have the regex database in there. So we try to do kexec. Then we see error from the server, deny pod exec based on pod. You can't connect to any pods with database in the name or the namespace C7N system. And also, if we go and take a look at the pod itself, we can see here that the auto label user action ran. So we added the owner contact equals Kubernetes admin, because that's who I'm running as. And then we also added the admission Cloud Custodian IO message, missing label on there as well. And then finally, if we want to take a look at something that's not a pod, we can apply our deployment here. And just take a look at the deployment. So this is just saying, I want to create this Nginx deployment with only 2 replicas. And we had that policy earlier that said you have to have at least 3. So if we apply that as well, you can see we get that same error saying that failed admission due to policies require at least 3 replicas. So that's it. That's a quick demo. Sorry about the technical difficulties.